The Earth runs on energy. The amount of energy that hits the Earth in just an hour is greater than all the energy used by us 7 billion humans over the course of an entire year. The story of how we use that energy is about technology and resources, but it's also about culture. So we're going to take a look at the role of the flow of energy through all the activities at Ensiladomini Sisters in Donaldson. We're going to look at our energy present and our possible energy future.
A high efficiency furnace would be 95% efficient, so for every dollar you put in, you get 95% heat energy back, and 5% is wasted up chimney or vents. Geothermal, it could be 400% efficient, so it's night and day. The coils are down on the bottom in the muck, so ideally ground temperature would be 55, pretty constant. Being that it's in a lake and not buried in the ground, it varies, but the coldest it ever gets is 30. The warmest is probably 60. This is the most important part of the whole system. This is the line going back to the lake. This is coming from the lake. You're either extracting heat from the lake or you're putting it back in, depending whether you're in heating or cooling. These are the 2 pond loop pumps. One is running 24/7. How the water comes back from the lake, works its way through the building, through all the heat pumps, comes back down to the pump, and goes back on out to the lake. The refrigerant runs on the inner tube in this coil and gets carried over to this air coil and dissipates the heat through the fan, heating the room. So it's absorbing heat out of the water in this coil, expelling it into the room through here continuously.
The majority of it is gasoline. I have between 35 and 40 vehicles and 5 golf carts to take care of. We have 1 diesel bus. We have 1, 2, 3, 4, 5 Toyota Prius hybrids. 1 electric golf cart. Everything else is gasoline. You can't get any more energy from a smaller amount than gasoline right now. And we don't have any way to compress hydrogen, hopefully in the future.
So what does the future hold? You know, there's all kinds of new technologies coming on, a lot of research being done. Solar and wind is being rolled out basically faster than any other technology. They're installing more capacity of that than anything else, and they're retiring old coal plants. Now the challenge, of course, is can that electricity still provide the same quality of service that we're used to? Can it still be deployed in, all over the world where still people need more energy? And are we going to be able to do this, roll this out fast enough in order to avert a lot of these resource concerns, carbon dioxide levels, acidification of the ocean, all these problems that these fossil fuels are presenting? Are we going to be able to roll out these renewables fast enough? So some of the technologies that we're looking into is electrifying our transportation. So one of the things you could do is move from a gasoline powered vehicle or transport to electric. Now, of course, you still have to use, coal or whatever is powering the electrical grid, but that grid is slowly getting cleaner and cleaner every single year. So you can start to try to do both at the same time. You can try to clean up the grid and electrify your vehicle fleet. Now, so for example, this all-terrain vehicle is all electric. So the advantages of that are that reduce fuel cost, hopefully reduce maintenance costs, and it's also less noise pollution, less local air pollution. From a wildlife perspective, you can get closer to wildlife. You can maintain a more quiet atmosphere on the grounds. It is still kind of a newer tech, so you do take a little bit of risk of things that you're not used to, basically. And it's really pretty simple. It really is as easy as just plugging it in. So at the end of the day, you plug it in, lock everything up, and you come back in the morning to a full battery. Same principle exists for modern electric cars that have the same safety standards as any regular car. Their prices are a little more expensive now, and they're coming down every single year. The newer models that are coming out have 250 miles of range, whereas the early ones had very limited range. So that's something that's changing really fast. So in addition to what's happening at the grid, you can also do your own, we have our own wind here at the center at Donaldson. That's challenging because it's intermittent, it's a small system, it's not producing a ton of energy, but now solar energy is becoming a lot more common. School districts are putting them in, so it's something we're looking into. We're getting a consultant to try to figure out if that works for our site. Another thing that we're trying to do is also look at energy efficiency. Every time we have to upgrade equipment, boilers, chillers, lighting, there's a new technology out there that's usually more efficient. So we're in the middle of looking at contractors who can come in and do a total LED light upgrade, which should further reduce our lighting demand by half. And that will just allow us to do basically the same or better quality of light for basically half the ongoing cost. So those are some of the things that we're looking at for the PHJC Energy Future.